Everyone, welcome back to the Cloud Native live stream hosted on the AKS Community YouTube channel. My name is Josh Duffney, and today we'll be diving into some open source work. So the last live stream that I did was with John McBride. He's a software engineer at OpenSauce, previously AWS. And we had a quick chat and discussion about like how to get started in contributing in open source. And to be honest, for me, it took me a lot longer than it probably should have to get involved in some projects. And so my main purpose with this particular live stream and the previous one was to kind of show how I went about doing it. So that way, at least it might not be the best path, but at least there's a path or something that other people can follow to contribute. So to kind of recap last week's session, what I've been doing is I've been using a particular open source project. So one of the recommendations that from myself and from John would be to select a project that you're familiar with, that you're maybe a power user of or super user of. And for me, one project that I'd been using quite a bit in my different talks and so forth like that and presentations was an open source project called Ratify. And so if you're not familiar, Ratify is an emission controller. And at first I was like, okay, well, words to describe a project and the way I don't understand the words. That was me in the beginning of it. Essentially what it does is it has a set of verifiers it runs on a Kubernetes cluster. So it's made for container deployments. And then it just checks to make sure that your artifacts, your container image have particular assets on them. Uh, Probably maybe a signature or something like that. There's other verifiers in the works. And what it does is it checks the image for those things before it lets it run on the cluster. And that's where the admission control comes from. And so that project, I've been using it for a while and things kind of slowed down for a bit, towards the end of the last year. And so I took that time to do some heads down development work. And yeah, yes, a good intro. I spent about, I don't know, maybe hour or two trying to put that together. So hopefully you like it. It's good. But yeah, so there's kind of Ratify and why I chose it. I chose it because I've had some familiarity with it. I knew what it was that the thing should do. I didn't know it had a CLI, which is what I used to develop. So that was a cool little adjunct. They kind of the sell that I want to do is I learned a tremendous amount in this process. I learned a lot about the project, but I also got to learn about a lot of interesting engineering problems. One of the main ones that I kind of took away was, how do you maybe not correctly, but properly, or how do you do a plugin model that has a nice clean contract between the plugin and the other one? And I started to realize a lot of these open source projects that I've been using, they adopt a plugin model, meaning that they allow extensibility through some kind of external program. And a lot of them adopted the pattern of just using an executable binary, which we'll see that up in the live stream. But there's got to be a better way. And so I was looking at some gRPC. And so the gist there is you just get exposed to some real world problems on a scale that you don't usually get on kind of your own pet project. And then the third benefit there, the third thing I'll note before we jump in is I got to meet some really awesome engineers. I got a lot of good mentorship from one particular engineer that I wouldn't have been able to complete the issue or get the PR submitted without his help. And so there's that sense of community that John and I talked about last week. And so that's kind of the three main points that I want to kind of hit before we dive in. So to start, this session is going to be focused on kind of sharing what I've done so far. So it's spent about 2-3 weeks, 2 weeks getting acquainted with the code base and about a week coding the solution. And then I submitted the PR and had it reviewed yesterday. So I have some comments in the PR to review. But what I want to do is kind of take you on that journey that I went to get to PR submission. And then hopefully that'll give you some kind of a model. And also if I have some bad code development practices, please feel free to educate me. So more than happy to adjust my workflow. I'll probably be switching. I see Tech Doofus in the chat. I'll probably be switching between in NeoVim and VS Code. So just be warned. There'll probably be a little bit of shaming for that. But I'm still switching back and forth. But anyway, let's take a look and first start with the issue. So I talked a little bit last week about how to select the issue and how to talk to people, and make sure that you're going to select an issue that's a good first issue, but also one that's going to be impactful, one that they'll actually care about. There was a really good quote that I got from Vinicius, who's a team member of mine. And he kind of gave me some advice is, make sure that you're working on a problem that other people care about, because that way that you don't need to sell them on your solution. They're already sold at least halfway because they agree with you on the problem. So with that said, let's change the layout here and share my screen. Screen one. So yeah, just to put this into focus. Thanks, Harry. Thanks for joining the chat. Long time no see. Yeah, so like to set the stage here, let's first get our head wrapped around the problem. And so there is this issue. The issue has some good text, but the context that I have here that I'll share was also a couple of conversations with the maintainers of the project. So currently, Ratify interacts with external plugins via standard in, standard out, standard error. So the standard in, so there's this JSON that gets passed into the plugin, it gets configuration, and then the plugin does some stuff. In this case, verifies some kind of OCI artifact, and then it sends it back over standard out, and standard error. Uh, and so the problem right now is when Ratify is getting that messages back, so standard error and standard out are coming back into the main program. It kind of throws away all the other output except for the JSON response it expects. And so that was the task that I was set out to do, which was like, how do I parse the standard out and standard error in a way that I can retrieve the messages and then later on return the expected JSON payload? Because the current behavior was if you added any kind of debugging messages inside the plugin code, it would error because it couldn't unmarshal and marshal the JSON that was being returned from the plugin because there was an extra line of output. And funny to note, a lot of this actually learning Vim last month or the month before, and just the concept of buffers and all this other stuff was actually super helpful in building some mental models for this work. So it's really fascinating how you just kind of decide to pick up something and then it becomes useful later on. There's a really good article. It's called The Usefulness of Useless Knowledge. And I love that article because it's talking about academics and kind of the forefront of studies. The people that often make the innovative discoveries don't know the purpose of the discovery. It's practitioners later on that will apply it. And there's also a really great book in that same vein called Range by David Epstein, in no relation to the island. But he wrote a really great book about generalists, and I think it's super pertinent to those of us that work in technology because there's just so many skills it can acquire. And his main point is that they will combine in unique ways that will make you even more valuable than the hyper specialist. So great book. If you like to read, I recommend that. And if you don't, definitely check it out on Audible or Spotify probably has it. So that's the main problem is I need to figure out where in the program this is all going about. And so this was, kind of fast forward and save you some time, but I'm going to pull up the Ratify repo and show you where the executing logic is going. And then what I'll do, what I ended up doing, and this is where people can kind of give me some guidance with Go development, but we'll dive into kind of some pair programming. And I have some other code on the side that I'll be referring to, but I'm going to rewrite it so you can see kind of the process I went to create kind of a mock program application with a binary executable, so I can manipulate the standard in, standard error without all the complexity of the Ratify application. So with no further ado, I think we have, let's get the Windows terminal up here. Close that one. This one. For those in chat, let me just change the repo. I think GitHub, and give me a thumbs up. Did some testing with the font size. I think it's going to be a good size, but if I could get some thumbs up when I get there, that'd be great too. Ratify. Let's see here. Let's get checkout. Where did that two words? just to appease a good friend Tech Doofus, we will use NeoVim to navigate this. And I should do another stream just on that because I had a lot of fun. So I've got a couple of plugins now, and I've got some. It's workable. I think the only thing missing right now is I need some Copilot experience, and then there's just a couple of the rough edges. But anyway, if we look at the Ratify repository, thanks Ryan, appreciate it. If we look at the Ratify repository, um, this I did ask for some help here. I was like, okay, so tell me where the plugin's being executed. If we look in here, have our plugins. Um, so Ratify has two types of plugins: a refer store. So where are the artifacts that you are looking for stored? Most of them are going to be in some kind of OCI compliant registry, like Azure Container Registry or some kind of a local registry. Um, I, for this demonstration, have a local just distribution. So that's the container image. It's from Docker, and it lets you just host like a local temporary registry that you can test with. But what we care more about is the verifiers. So in here, they're working on the SBOM verifier. One of the built-in ones is the notation. So that's another project I've worked on before, and that does digital signatures. And I opted to modify the sample. So this is just to get you started. And there's a little bit of abstraction here, but essentially in here is the contract, so to speak, between the main program and this. So the main thing that we want to care about here is this verify reference function that is ending up being passed all the way back to the main program. And it's actually what's called when the binary executes. A lot of that logic is wrapped inside this Skelly plugin, which is kind of a package that abstracts and bundles all the logic and types and stuff that you want to pass back to Ratify. Don't need to go into that too much. So that's the plugin. What I need to do is find a way for messages like this, thump print line, to return and be processed. That's the main goal. Right now, if I add this in here, Ratify will fail because there's more output than it expects. It's only expecting the JSON to be there. So the next little hunt that I had to go on is, okay, what inside of the main program is Ratify calling? Like, where's the verify reference and stuff being called? And that is actually in package common. And I did go back to VS Code for this just to follow along where everything was coded. I need to get better at searching in NeoVim. Plugins and this exe.go. So if we look at here, I'm going to be there's two variants of Ratify. One of them is the command line. So there's a command line tool, and then there's the web version, which is resources deployed to a Kubernetes cluster, which is a different kind of setup. So it can also be compiled into a binary format, and that's what I use for testing, just to keep it simple. But right here, starting on line 49, we'll go up and highlight it, is the method that executes the plugin. So here's all the logic, like right before the binary plugin is executed, it is, So in here you can see that we're creating variables of byte buffer for standard out, standard error, and then we're mapping them and connecting them to the OS exec command. So that is what's going to invoke that's a standard library package that will invoke an external plugin. Telescope. I've heard that before. I'll have to check that out. Oh, and just in case you're wondering, this is a Zevia. I had someone confuse that for a Bud Light the other day. But yeah, Peter, I can definitely share my NVIM config. I think I have it in a public repo. Let's see here. Dot files. And it is public. Good deal. So here, let me know if that gets distributed to YouTube. But yeah, that is the dot files. I can put it up on the screen too. There's where the dot files would be. So that's where all my I think I even have my Tmux config. That was actually a great a shout out for Tech Doofus. He helped me set that up. So that would not exist. It's on YouTube, but not Twitter. Okay. Interesting. StreamYard must have a one-way relationship with X or Twitter now. Yep. YouTube for the win, though. So looks like most people are tuning in there. All right. So back to the code. Let me get this repo off the screen. It's in the YouTube comments if you need it. Yeah. So this execute plugin, it takes a context, a plugin path, and then the arguments that are being passed in, and then the standard in byte data. So that's going to be the data that's essentially the configuration. So the plugin is looking for a configuration JSON that gives it information about, like, what am I trying to verify? Where does the object exist? This will all make more sense later when we dive into it. And then it returns, if we go scroll over, it returns some bytes. And that bytes is actually going to be the JSON payload of the response. That's actually what we need to modify later on. So if we go down here, there's some debugging already set up for before the plugin executes. It tells me some information, like here's your environment variables, here's your arguments, and this is the standard in blob that's being passed in. So that's super helpful. The problem is like once that plugin executes, it's a black box and nothing's returned. And so that's what we're here to fix. And then there's some nice retry logic here just to make sure that the file isn't busy. And then, do a couple retries, and then if it can't, break out and throw an error. And then down here is where all the errors are thrown away. On line 97, it remaps standard error into standard out. So it merges the messages together in case they incorrectly wrote to standard error. And then it just throws away the extra error messages with the blank identifier on 98. And then returns the JSON bytes. So this is the code, the main section of the code that will be changing. So like I said, what I like to do is to break things down as simple as possible. And so what I often do, if we just, see here, I don't think I'm in Tmux, unfortunately. It's spelled Tmux, right? It'll let me. Now that I'm in here, I'm going to change to projects. I think I created a folder for live stream. Yeah. Here I've got a clone of the Ratify repo and then this example plugin. So what I like to do is just get things working. So if we open up nvim in here and create a new main.go. And so what I'm going to do is I'm going to rewrite the prototype that I created to kind of test out this stuff. And so what I need to do is create a main program that acts as what Ratify is, this main program that's executing binary. So I also need to create another file in here called like plugin.go, and then actually compile that and create an executable with that. Go does have the ability to do other types of plugins. It has a plugin package in the standard library, but that actually just mounts it into the main program essentially. So it kind of merges them. This is a little bit different where the requirements of the Ratify is that the plugin is compiled and it's just an executable that communicates with the main program and standard in, standard out. So I'm going to replicate that. So to get started, let's just do the main function here. So package main, and then import. And we'll need fumped log. And just for, let's see if my language server will. Oh, there we go. Okay, I didn't open it. I created it, but I didn't open the file. So now my main is in the current buffer. So package main. Now we've got some language server stuff going on. I want font, log, OS, and OS exec. And really all this is going to do is execute the binary and then return back stuff. So if we do function main, say calling plugin, and then the input, we're going to grab from our arguments. And so instead of using the flags package or anything fancy, I'm just going to use the OS args and then grab the first input there. And then we will create a CMD with exec.command. This will, I'll pass in, I'll compile the binary and I'll give it a name plugin.go. And then we'll pass in the input to it. And so that's going to call the plugin with particular input. So one thing we can do just to test it out is there's a combine in the CMD. So it will merge stderr and stdout into one message. And so we can do that to begin. CMD combine, put, and then if the error does not equal nil, we'll log fatal. And show the error. Errors. We'll output the output. Space S. Print F. So this is the basics of it. It's just we need to call a plugin and see what we can do with the output. All right, so now if we go back, let's create another file called plugin.go, and we'll open it up. And let's see if we can simplify this. Yeah, we could probably keep the JSON in there. So if we do package, this is going to be a totally different program. So we're going to recreate main and it'll yell at me that I have two mains in one file location. That's fine. Let's leave import blank until I know what I'm going to use. So function main when os.args. I'm going to check the length. There's not the name of the executable being passed in and then the value. Oh, actually, if it's less than 2, yeah, then we'll error. So funct ln do usage do upper string. Yeah. Plug in. That'll probably be. We'll leave it for now. There we go. So S, the string that's being passed in, is going to be OS args 1. And then the output is going to be to upper. So we're going to write a function here. Essentially, what this plugin is going to do is just uppercase whatever text we pass in. So out and air. And that's going to be the function that we'll define down below. We also want the fatal logs to be passed back too. So example, I'm doing JSON, but I think that makes we can make it simpler by just doing text strings for now. We can make the JSON, add it later. Line, and then we can just do out. That should work. So now we need to define our upper function. So function to upper, we're going to take an input, which is a string, and we will return a string and an error. And then one way I was using the logros package, but we don't need to do that. So we'll just do print f uppercasing. So now we need to handle an error. So if it's blank, we're going to return blank string, and then we're going to create a new error. That probably, but input string is empty. And for return, we'll just do strings dot to upper, and then return that, and then no errors. So new errors dot new. We need OS and errors. So that fancy trick there to create a new panel, that's tmux. That's super cool. Excuse me. All right, so just to test the plugin, make sure I got my files here. We could do go run plugin and pass in a string. And maybe we should do a new line here. There we go. So we get our two messages. We're getting our return, but we're also getting a message in there. And so this is the problem that we have is we're only going to get hello currently if we move it in the main program. But I want to be able to read these lines and output them one at a time, and preferably take return and always put it at the last as the last thing that's returned from the program. So now we can call that with go run, but now we need to build it. So I'm going to use go build -o, and then I'm going to output it to plugin.go. Well, it'll be the name plugin with no executable because I'm on Ubuntu. I don't need exe or something like that, like I would for Windows. And then the program to compile would be plugin go. And then I can do the same thing here, plugin hello. I get the same results. So now let's try to execute it from the main program. Go back up into main. Make sure I've got need.go because it's a binary. So let's just give it a try. Go run main hello. Okay, and it works. Notice I have 3 messages now because the main one on the main program has something writing to standard out, and then the plugin has 2 messages coming back from it. And what's neat is I can take the output. That's interesting. Oh, yeah. So this is added as the return. So this output, this here, what I'm highlighting in yellow, all of that is one line of output. And so what we'll need to do is to parse them with probably, I think I used the buffer IO package. And that way they return on multiple lines instead of just one, separated by their own new line character. So let's do that. Where is that code at? It might be a good time. Like, check the chat, see if there's any questions. Has anyone done this type of stuff before? Have they had to parse standard error, standard out in Go? Anybody? All right. Keep on keeping on. All right. So let me try to find. Here we go. So now that we've got a main program that is calling it, now what I want to do is I want to map the It's kind of like what the Ratify was doing. They created a new buffer for standard error, standard out, and then they mapped it into the exec command. So that way they could manipulate those lines. And so that's what I need to do now. So I'm just going to go ahead and delete these lines and we'll start over here. So the string is going to be os args1. That's going to be the input that's being passed to the plugin. And then I want the CMD again to be exec. And we're going to run plugin. And we'll pass in the string. And now what I'll do is I'll create some variables for the buffers. So when I want an out buffer and an error buffer, and those will be bytes.buffer, bytes buffer. And then, let's see here. Note type, that's probably a good one. Yeah. So we create them and now we need to map them to the CMD that's being run. So if we do CMD standard out, we want that to equal, we'll dereference the out byte, and CMD standard error, we'll do the same thing, error buffer. And then we run the command. And I'm not remembering all this top of my head. I've got other code that I've written and I'm trying to piecemeal it back together in here to simplify the example. I wish I was that good. I wish I was that good. Maybe someday. So error, if error does not equal nil. So what I want to do now that I have error buffer being returned, so that's what line 17 is allowing me to do here, is it's mapping the CMD standard error. So all the messages that come in standard error from the plugin are going to be accessible to me in this error buffer. And that buffer, you can think of it, use the mental model for Vim. So what I have open here, starting on line 16, package, this whole thing, that's a buffer. And so standard error is literally that, a buffer with each line having its error messages or jumbled or what have you. But with that, I can begin to parse those messages. And so if there is an error from the plugin, if standard error is not empty, I want to create a scanner and then parse that line by line and return it. And so that's what you'll see here. If the error is not nil, if standard error has stuff in it, we want to do this. Buff.io new scanner. And then we want to point to the error buffer. So I'm creating a scanner from that. And now if we do or scanner.scan, so I'm going to scan that buffer. And the line is going to be scanner text. I could do bytes too, but I'm going to do text. And then I'm going to use fprintln to specify which writer that I'm going to use, what writer interface. And so I'm going to use OS standard error. So that way it'll output standard error in my terminal when I run it in the main program. I don't want it to merge with standard out like it was previously. I could even tag it here. Standard error, plugin standard error, and then the line. So I'll process all of the error messages in the plugin, because that was another thing that was happening is, yes, when the plugin returns a failure, when it's executed, we'll capture the main error, this one right here. But if there were any additional errors written to the standard error buffer, they would be discarded. And all we were getting was the main error that was returned back from plugin execution. So that should take care of the standard error. Now let's work on the standard out. Calling is only at an adventure of advent of code day 1 through 5 level. Okay, well that's not nothing. Those advent of codes, they're not a joke. Some of those are pretty tricky. Actually, when I just to pause for a second, when I first started learning Go, I kept it way too academic. So like the advent of code probably would have done me a lot of good. I eventually started doing some leak code problems with Go, and that actually helped a lot. Yeah, getting some reps in. But I have to say, like contributing to the open source projects, that has sharpened my skills probably more than anything. Granted, you have to have some familiarity with the language or programming in general to be able to do it. So there is a little bit of a knowledge barrier there, but yeah, like I've learned more from the last 3 weeks than I have like in months of kind of tinkering and building my own little like URL shorteners and stuff. So yeah, that's another reason why I'm kind of promoting it and talking about it quite a bit because it's just such a good skill sharpener and many other benefits. But yeah. All right, so let's go back in here. So we've got standard error. Let's dive into, yeah, standard out. Okay, I'm trying to reconcile my example here because it's got a lot of advanced logic that I didn't need, which is another lesson learned. Anyway, yeah, we want to create another scanner for the out buffer. New scanner. And here's a cool trick from TechDoofus too. So if you have tmux, um, I can switch between them. I exit insert mode. See how I can switch between them. But sometimes you don't want your bottom pane. You kind of want to refocus on here. So if you hit in tmux, it would be Control BZ, whatever panel that you have selected, it'll take up the full screen. And then to get it back, you just would navigate down to the other panel or hit Control BZ again. It's like Zen mode, I think, in VS Code. I believe that's what it's called. I'll do that. Now it deleted my scanner. I'll create it again. Buff. Go new scanner. And we want to pass in the out. And pointers and go still confuse me a little bit. I understand them decently, but yeah. Was it Luke, good friend of mine from Cloud Skills community? Anybody familiar with that? Um, he just says that he puts the at symbol, not the at symbol, and sees what Go tells him is appropriate, which is fair. You can do that. So scanner, yeah. So now we need to loop through it again. It's on the fly. So line equals scanner dot text, and then I really just we'll just print out simple and just print this out. So func.print fprint. I don't really need to do. Well, we'll do it for completeness sake. And by default, it goes to standard out, so I don't need to specify this. Actually, we'll just do that. Func.println because that goes to the right writer, the correct writer. F. There we go. Plugin standard out. And then, I'm going to need, that should work. Yeah, line. Should work. Do ln. I don't need that. And closing brackets. So hopefully this creates a scanner and gets all the outputs. So if we go back into here and we run the plugin to get an error, go run plugin. Actually, just we'll run the binary. It says uppercasing blank. That's a good call out. Let's just update that quick. Let's move this in here. Let's move on here. Good. Oh, because I need to paste. Yeah. That way, if it is error, if it's empty, it'll just error and it won't put uppercasing. Because there's no need to output this message if there's nothing in it. So let's recompile that. Go build. I'll try it. Now we just get string is empty with the timestamp. Cool. So now let's try to run the main program and see if we get our desired results. Hard to beat, just getting stuck in. What were you getting stuck in, Ryan? Hard to beat, just getting stuck in. All right, let's see here. Go run main hello. Nice. And if we want to see the error path, we would make it error. Yep. Nice. Okay. Well, that's taken long 40 minutes already. That took a lot longer than I thought it would. All right, so essentially that's the gist. There's a little bit of a fancy logic with the JSON parsing, but now that you understand it, I think I can show you some of my old pseudocode or mock code, and then we can kind of look at the Ratify environment before we wrap up the live stream. And then, yeah, if I don't get far enough, we'll just do another session and continue hacking on the PR. So let's go back. I tend to I have a projects folder, and whenever I'm hacking on something, I just create a folder in here, and I often misplace what I did with different things. So I think it's plugins and a binary. So I've got some examples in here of creating an interface that the plugin has a contract with the main program too. And that seemed like a really nice way to go about it, but it would I'd have to do a lot of refactoring to implement that in the Ratify. So I pivoted to the binary. So let's just hit that. And now that we're in here, I'll open it, NeoVim again. Open up my, what is it, tree viewer, net viewer? I don't know what it is. Something that gives me file navigation. But this no type actually has the most up-to-date logic. I don't even know why it's called no type, but it is. And in here, the only difference is I was passing, if we look at our plugin file, I created a data structure for the plugin, the input output, to be in JSON. So that way I could get a better idea of if a line has JSON, how do I validate the JSON? Is it a valid JSON object and so forth? And so if we look at this example, it's very similar to what I just wrote, but that just handled line by line and strings. This handles JSON, which is what was needed for the PR. All this is the same, 20 to 38, 37. And then 38 kind of changes where I'm creating a generic interface. So the interface can be of any type and go. And then I'm also creating a buffer, a bytes buffer for the result. And the reason for that is as I go through here, the standard error is the same, but the standard out's different because I need to check, does the line contain kind of an open curly brace? And if it does, then I want to try to decode it. And this is where I got a little too far in the weeds and I had to pull myself back. So I'm glad that I can kind of share this lesson with everyone on the call on the stream. But anyway, what I was doing was I was going down this rabbit hole of all the various ways that JSON could be represented in standard out. So it could be on a new line, It could span multiple lines if you use something like Marshall indent, and then it makes it nice and pretty with tabs. And so I started going down this rabbit hole of, like what if the string, so this right here handles is this whole line, of the buffer. Say it's line 2, line 1 has hello, and line 2 has a JSON object in it. Is the whole line JSON? Then I can check and say, decode the string and it'll go all the way through. But then, what if it errors again and the JSON's actually on 2 lines or multiple lines? And so I found some logic. I had some really good help, by the way. There's a Golang, or I think it's just a Golang community on X Twitter, and there's some really good heavy hitters that really helped me work through this particular problem. And so essentially, what this is doing is taking the index of the string, like start and end, and then matching, and then saying, okay, well, this is now a complete JSON object. Um, Go ahead and try to decode. And so that's what that does. And then um, I got this is about as far as I got. And then I was like, well, there's another use case where this string from message one is on the same line as the opening curly brace of the JSON object. And I got a little ways down that road and then realized Ratify only outputs JSON to a single line. And so really I could have just stopped right here. I could have stopped on line 47. And so even though it was an interesting problem to solve, I stopped myself from writing an entire like JSON parser library, because this was good enough. And I had to kind of detach and pull myself back from um, that particular sticky issue. Well, let's see here. So we talked about that, and then what I do is I unmarshal it, or I marshal it into the object, and then I write the string to the results buffer. And the reason for that is, and this is actually in the Ratify code too, is because I want to process the standard out messages first, and then return the JSON payload, so that way it can be passed into the main program and then outputted later by the verifiers inside the main program. That's all that. If this is interesting, I don't have this anywhere, but I'm thinking about putting together, or maybe revising or resurrecting everything I know about Go repo, and just kind of putting all these miscellaneous code samples in there. Um, and yeah, so if you think that would be valuable, if you're interested or have run into these problems before, just hit me up on Twitter or whatever, and I can send you a link to it. I can put it up on GitHub. But anyway, let's switch now to Ratify repo for the last 10 or so minutes. And this will be the time, I think Cooper said he had to go to a meeting, so maybe he won't shame me, but we're going to go into VS Code. So GitHub, actually, let's do live projects, live streams, and then Ratify, yep. And then we'll open up VS Code in here. And the reason is VS Code has awesome dev containers. So we'll reopen it in the container. And I should start Docker desktop. All right, let's give this a try. Sad Panda. Okay, it is running. There's my registry. There very well might have to be a part 2 for this one. Okay. Give it a minute. So has anyone used dev containers before? Care for a brief intro? Well, way back in the day, what was that? Oh, 5 years ago now. The team that I worked on, we created our own little Ansible container. And so we had our Ansible development environment in a container, and we maintained a little Docker file for that, and then we mounted our code repo as a volume into the container, so that way we can manipulate the files. And the dev containers just takes that to a whole new level. So essentially, what it is it's a set of files that define your development environment, and so it'll bootload a container image for you. It'll install the tools that you tell it to. You can even have it run bash scripts. I did this for my secure supply chain talk and installed, I don't know, probably 10 different CLI tools into it. But what's really nice is it doesn't stick on your machine. So it's all in a container, and that container can have everything that development environment needs. Working through this, I found that there's a couple tools that I needed to install, but we should be able to figure that out. And depending on how much stuff you put in the dev container, it can take a while to load, especially if you're on slow conference Wi-Fi, like I found out at Build. That took forever. I have not tried VS Code with the mvim. Well, I don't know if there's an mvim, but definitely the vim extension. I do have that enabled, so I still have my key. What are they called? Motions, I think, is the proper term. So that is enabled, and I do still use those. But the thing that's really kept me coming back to, while this is building, we can kind of chat about it, is the panels, and the windows in here, and being able to seamlessly move from my terminal and my editor with just keyboard clicks. I'm sure I could remap some of these in VS Code, but just to be able to do, start NeoVim here, open my Explorer, um, open up my files, open up package again, and then I can split, and I can say, hey, open this on panel B, and now I can go between the three. You can see down at the very bottom it says normal mode, and I can move between. And then if I want a terminal session, I just hit, oh, it finished. Control B, and then shift quotes. Now I have another prompt, and I can adjust this super easy with my keys. Like that is just, that's awesome. Like that, I don't know. I love it. I've actually found navigating code in here. When I spent about a week of just reading the code base, I did it all in NeoVim, and it was helpful. And I can focus on these panels, and I can move down on my terminal. Yeah, so that's just the navigation niceness between Tmux and NeoVim has got me coming back, got me hooked. I miss it once I'm back in VS Code, that's for sure. But all right, are we good? Yeah, we're good. So we'll open up another terminal in the Ratify repo. What do we want to do in here? Oh, so yeah, to wrap up the live stream, let's just talk about setting up the Ratify development environment so that way you can run the command line. So if we look at the make file, minimize the terminal for a second. There are some nice shortcuts. I forget what build files call them, but we can build the plugins and we can actually install it. So these are super helpful. You can just run a couple make commands and it'll stage your whole development environment. And there's also a make CLI. So if we were to come in here, make build CLI, no rules. Oh, I spelled build wrong. There we go. It's going to build as, puts in the bin directory, and then the install will move it to, it'll create a, excuse me, .ratify in your home directory, and then, run it like a normal program. let me get, let's see here, dot ratify. There we go. That's kind of what we'll need moving forward. Yeah, just a quick shout out of appreciation. Thanks for, everybody coming and hanging out in the chat and communicating. It makes it a lot more engaging and interesting and fun on my end for sure. So I appreciate you guys stopping by and chatting and seeing what I'm up to. And if you have any suggestions on other things that you want to see, yeah, just let me know. Hit me up. I'll be doing a session next week with a coworker of mine, Yosh, to talk about WebAssembly. It's something that I can't open my inbox without seeing these days, and it seems really promising, but I don't know anything about it. And so I thought I'd just record a conversation with him, asking all my silly questions. And so if you want to tune in, it's already scheduled on the AKS channel. It'll be next Wednesday at 9:15 Eastern or 9:15 Central. So whatever that converts, and it'll be recorded, of course. So if you can't make it, if it's like four in the morning or whatever for you, definitely don't stay up for it. The build is taking a while. Okay, I've got time. All right, so we've got the binaries. If we look in the bin directory, we have Ratify. So that's our Ratify CLI. We do, let's just change into bin. We've got a command line, and it was written, one second. This command line was written with Cobra, which is not surprising, which John from last week's live stream is a maintainer for. So it is indeed a small world. If you're curious about what the code looks like, if you go into CMD, Ratify CMD, these are all the functions. So if you look at the help system, let's just pull this up, Ratify, we see all these like refer and resolve. And then here's the code right here. So here's verify. Well, minimize this now. See, I need my NeoVim back so I can move all these panels. Verify. So here's the logic for verify, and we could, set some breakpoints and debug and do all that good stuff. The problem with having external binaries executed is you can't debug into them. You can't. You'd have to debug them locally or isolate it. So anyway, that's the CLI. So let's go back and install it. We also want to make the plugins. So make plugins. Yeah, build plugins. I think I could just do make build and it would combine these two, but and this is building all the plugins that we looked at the very beginning, which are plugins verifiers in the refer store, where we kind of care about the sample. That's what I'm going to try to invoke here quickly. And then make install. So now if I change to .ratify, I have my ratify executable, and then I have my plugins. So here's my plugins. Here's sample. So yeah, we need to do here. I think I need to create, got some notes. Need to create a registry. Already have. So what I'll do is I'll just share the command. So what I need is a local registry. I could spin up an Azure resource. I could spin up ACR, but I want to do the local testing. And so there is an image, just a registry image from Docker, that you can do, and it'll just run a local instance of a container registry for you. So Docker run, it's going to be detached. Give me the port numbers. Set an environment variable, so I could delete if I wanted to, and then I'm going to name it registry. So I have that running. I just have to start it in my Docker desktop because I rebooted my computer. Um, and there you go. So now what I want to do is I want to pull, I think I already have all this, but if we want to pull Alpine latest, essentially to use Ratify, I need to have an artifact in a repository, which is typically an image. And then that image needs to have some kind of refer artifact. And you can create any artifact you want. And so we'll use another tool called ORAS to attach something to the artifact. So other things that are valid things that you can attach to an image as a signature. And then that will be available through the referrers of the image. So that way, when you look at your image, you can see in the metadata, like, oh, there's some kind of object that refers to this image. What type is it? And that type is what Ratify uses to validate. Like, does this particular thing exist? And then you can create all sorts of fancy rules, on top of it later on. But essentially, what I need is an image. Then I'm going to tag it, and I'm just going to create a new image so I can attach something else. So instead of latest, I want to do v1. So I'm going to have an image on my local registry called Alpine v1. And then, of course, I'm going to append the registry name to it so it knows where to push. I'm going to need some practice if I'm going to do some 2-hour live streams. Voice is starting to fade. So let's just look at the images. Yeah, there we go. I've got my localhost image and I've got my Alpine that I just pulled down. So now I want to push it to the registry. Again, I'm going to use a new image called v1. Refused. Why not add? I could do that. I do think that there is a NeoVim dev container plugin, so I could use the same files that VS Code uses to create the container. But yeah, it's something to try. Something to try. There are more hours in the day, right? More hours in the day. So I wonder if it's not liking that this is in my container reaching into another container. Let's Google it. Should be able to work. Sudo. It's not change anything. Someone says it does. Nope. Maybe no, that should be the right. Docker images. That Docker push. V1. Can I pull? Let's see here. Docker pull. So I know latest is already there. I pushed that before, so let's just see if I can connect to it. Daemon refused. Interesting. So this is my dev container. And this is the registry. And I can get to it on my local host because I don't get any errors. Well, okay. I'll have to figure that out. To show you what I'm trying to do, we'll just go back to my WSL instance. So let's go. If this doesn't work, then I'll be very confused. I'm in my Ratify, and I've got Let's see here. Yeah, we'll look at the commands, then you can see what's going on. Break this command down a little bit. And so this would work. I don't know why the container isn't able to talk to the other container. I'll have to figure that out. But what should happen is what's happening here. So I've built the Ratify CLI, and now what I want to do is I want to use it to verify some object that I pushed to uh, the ACR. So the missing command that you didn't get to see before we dive into this is the ORAS attach. So ORAS is a command line tool. It's another open source project that lets you manipulate things in a registry. And this is all that I would need to do is create some kind of text file. So I had already pushed up um, the image. So there was that Alpine V1. Right now, Alpine latest exists there and it has something attached. But really what you need to do, and it can be anything. It can be a text file. It can be a string, a signature. You can put anything you want in the registry and then refer to it. I'm sure there's limitations. You can't put anything, but a lot of things. But really what you want to focus on is this. So ORAS is a CLI tool. So you would just go to the website. There's download instructions there. Um, I don't think it's in the dev container. So that would be something I could do a PR for, just to update the Ratify dev container to include downloading ORAS for you. So you don't have to worry about it. But it's the ORAS attach command. And then this is what's super important, this artifact type. So this can be anything. If you look at notation signatures, they've created their own custom type and namespace there. I made up my own vendor debug config, but that is what Ratify is going to use to validate. Like, does this artifact have this artifact type? So that's super important to have match in your config. And so what I'm doing is I'm going to attach this particular artifact with this artifact type to localhost Alpine latest, and then I'm giving it the text file, and that's just an empty text file. The only thing that's important about it is the name and the type. That's what exists there. So if we look at the ratify command, ratify verify is the command. So we want to verify that this artifact type of application VND debug config exists on the subject, which would be the image of Alpine latest. And then we're passing in a config. And this config gives the different rules and policy and so forth. Then I'm adding the debug so I can see. And if we look, we can look at the config JSON. And there's a couple things here. The plugin that I'm going to be using for the store. So like where are the artifacts? It's going to be an ORAS registry. And then because it's local, I'm using HTTP. I don't have HTTPS set up. And then down here is the important part about the policy. So if it has, skip that. That's the built-in policy. Here is what I want to talk about. The version and sample and artifact. So this right here needs to match whatever you attached, the artifact type of the attached artifact to it. And I'll revisit this in the next stream too, just to recap, once I figure out the Docker stuff. But yeah, that's the artifact type. That's what needs to match what's being passed into its artifact type. So those two have to match what was on the ORAS attach call. So when we run this, this is all the information stuff because I'm doing the debug log. But as we were walking through this, here are the plugin messages. I'll review this on the next stream so we could see where the code got updated from the examples. But then here's the JSON payload that was returned. The main thing I wanted to get everyone acquainted with was kind of setting up, doing the makefile, building your plugins, building your CLI tool, and then staging your OCI artifacts. So that way you can actually do some kind of manipulation with the command line. Because I think that ratify, what other refers, resolve, yeah, those would all require some artifacts. But yeah, let's see here. That is a good place to stop. Like I said, we'll revisit that. Hopefully I'll get something up there next week so we can walk through that a little bit cleaner, kind of fumbled through that. I'll figure out the Docker issue or I think pretty sure it worked before. But yeah, hopefully that was some fun. Hopefully it's convinced you a little bit to maybe dive into one of your favorite open source projects. Like I said, I learned so much from this. Learned a lot about buffers, learned a lot about standard error, gave me a real practical problem to work on. Um, and then also I can feel good about the time invested because it was significant to get all this working. I know I kind of cover it here in a little bit over an hour, but I was like at least 2 weeks. 2 weeks to get acquainted with the code base and another little bit of time to actually figure out a solution to the problem once I had the problem quickly like solidified in my mind of what I needed to do. But a ton of learning, built some good relationships with the Ratify team, and learned some more Go along the way. So that's it for this live stream. I want to thank you all again for joining. Be sure to check out the YouTube channel. If you have any advice with the new layout, I've got a new little layout going on up there with the icons and stuff that was helpful or not helpful. Let me know. And yeah, just thanks for tuning in. Thanks, Ryan. Thanks for joining. I will catch you on the next one. So stay tuned. Check out the AKS channel for the scheduled updates. I'm going to work to be better on scheduling them more than 24 hours in advance. So that way you got more of a heads up. But yeah, thanks for tuning in, and I'll catch you next time. See ya.